promised yesterday when we were going through 9-1 and trying to find the different ways that we can write all of these, that eventually we would get formulas, that it's going to happen. We're going to get formulas. In fact, today is the first day of that. Now, I pronounced this arithmetic sequences. I need to tell you it is actually pronounced arithmetic sequences. Now, to me, that again is the old English thing, and whenever you do that, whenever you change a name to something like that in mathematics, to me it means that students would be less able to understand it. So it is pronounced arithmetic, but you absolutely need to think arithmetic when you're doing these. You need to think, the first time I learned arithmetic was when my teacher in kindergarten, first grade, handed out, either, little discs or M&Ms or Skittles, whatever they were doing, and said, all right, keep these 2 on your desk, I'll be back. And then they came back a while later and they put 3 more on your desk and said, how many do you have now? And started talking to you about the basic arithmetic. So we're going to define, identify, and apply arithmetic sequences. That first math that you learned was adding. Now, we're going to take it a step up. We're going to say that we can add positive numbers or we can add negative numbers, because we're not at the Skittles and M&Ms level anymore. We're a little above that. But what makes a sequence arithmetic is that we're always adding the same amount to any numbers. So it's a sequence of numbers where the difference, because if we want to see what they're adding, we're going to check by using subtraction. The difference between consecutive terms is constant. So they're not going to always tell us that it's an arithmetic sequence. They're just going to say, write a formula for this. Write an explicit rule. And we're going to check. We're going to see, yeah, every number it's going up by the same amount every time. Or it's going down by the same amount every time because they're adding a negative. And that value that we're finding is called the common difference. We're going to just use a lowercase d for that common difference. So part of today's work is just, can we recognize when we see it? So can we see that they're adding the same amount every time, or they're subtracting the same amount every time? And once we have that, can we use the new formulas that we get? Now, your packet looked a little bit different this time because the front page had a bunch of blanks on it. That's because as we move through the chapter, we're going to grab these fantastic formulas that they have for us, and we're going to put them on the front of your packet so you can use that as a cheat sheet when you're doing your homework. Because again, you're going to get the formulas for the test, but you have to know which ones get used for what. That's totally on you. So our sequence is going to work this way for arithmetic. They're going to add 1d. Well, then for the next number, it would be like starting with adding 2d to it, then 3d, because it's going to be adding d every single time. Now, when that happens, we get these really nice little formulas. So turn to the front of your packet, and we're going to fill out a recursive and an explicit blank in there. And I don't even have a spare because everybody took all my packets yesterday. So let's see, where are we going to go? So we're going to do the column that says arithmetic, and we're going to fill in, let's do definition. Let's do that part. In the definition, let's put adding a constant amount. So that's really the definition, that we're seeing they're adding a constant amount. And then, as you work down that column, in the one that says recursive, you want to put these two formulas right here. A sub 1 equals A sub 1. And then this one is A sub n equals A sub n minus 1 plus d for n is greater than 1. Bless you. And a little further down that column, you'll see an explicit spot. Ooh, that's kind of right in the line, isn't it? Let me see if I can move this down. There we go. The recursive one always talks about that previous term, a sub n minus 1. This is the one we really want, if we can get it, is the explicit, because this one is the one that uses n. So if we wanted the 50th term, we could just put a 50 in there, and away we go. So a sub n equals a sub 1 plus the quantity n minus 1 times d for n greater than or equal to 1. It doesn't make sense to talk about a -1 term or a -2 term or a -3 term. So we're going to start with first term, second term. Now, know that you can. There are books that start with the 0 term. We're not doing that. We're going to start with the first term every time. And that makes it easier for students to understand when they're first starting to look at all of these sequences and series. All right. That's going to be it for the formulas on that front page today, because we're not doing any of the add all the numbers up yet. This is a sequence. When we start adding numbers up, that's called a series. So we have to wait and get into that. So we should have 3 little blanks filled in. All right, I just want to make sure everybody had plenty of time to get the formulas done. I do see a couple people still writing, so get out of the way for a little bit. Anybody still need more time? All right, away we go. Here's the first part. Do we know it when we see it? I mean, that's going to be big. And I don't know if you noticed in yesterday's assignment, but we kept seeing these 3 little dots behind stuff. Those 3 little dots in math mean it continues on forever. They're not giving us a stopping number. Later on, we'll get a number for some of these, but we're supposed to know, hey, this is the pattern, this is what's going on, and it's going to continue forever. So I want you to look at A. And I know I didn't do one of these for you yet, but I don't think I have to. Take a look at those numbers. Is that arithmetic? It is. What did you see they're adding every time? So you just found D, the common difference. Now, do you agree that it's pretty easy to see when they're adding a positive number? Sometimes you have to think a little bit, because if the numbers go down, they're adding a negative. But you just check and see. Is it constant? Is it 3 for every single one of these? And it is. Take a look at B. Arithmetic? Nope. Add 3, add 5, add 7. Nope. So that one's done. I mean, that's all we are supposed to tell them. Is it yes or no? If it's yes, tell them what the common difference is. All right, let's look at, is the sequence an arithmetic sequence for these? So take a look at A. Arithmetic? No. Add 2, add 4, add 8. Definitely not adding the same thing every time. Take a look at B. It is, isn't it? But they're not adding a positive number. Or are they? Okay, so what are we adding? What I'm trying to get at is sometimes they're going to go down. And sometimes students say, well, they're not adding something, so it's not arithmetic. But if it goes down, yeah, it could be arithmetic. They just have to be adding a negative number every time. I hope we get an example. I think we do. When I looked at it last night, I remember there was one that had a negative in there. Yep, we do get a negative example. Alrighty, so problem 2 says, let's start using some of these newfangled things that we know. Analyzing arithmetic sequences. What is the 100th term of the arithmetic sequence that begins 6 and 11? Well, I don't know about you, but I don't want to do all 100 of them. So that means I would use an explicit formula. Because I'd just like to be able to put 100 in for n and get my answer. So then we write down the explicit formula. which is a sub n equals a sub 1 plus the quantity n minus 1 times d. Now what this says in real people language is, to find any term, write down the first term, then use this little formula to figure out what the rest of it would be. So here's our job. We have to put in a number for a sub 1. How can I do this? I'm going to put a box around the ones that we have to put numbers in for. And then we're going to simplify it and make it a nice little formula. So it'll be really quick and easy to put a 100 in and see what we get. All right, to find any term, we need to plug in the first term. What was it, or is it? Oh, careful. 6 this time. Yep, starting with a 6. Now, they only gave us 2 of them, but they did tell us that this was arithmetic. So that means we should be able to find that common difference. What is it? It is 5, because 11 minus 6 is 5. And like I said, we don't want to leave it that way. Let's simplify it. We know how to distribute, for goodness sake. Even though it's on the right-hand side, big deal. Give it to both of these in the parentheses. Because then we see we have a couple of like terms here that we can put together. Now, some books would write that formula as 1 plus 5n. Others write it as 5n plus 1. The 5n plus 1s usually win out. You know, it makes us feel kind of like our y equals mx plus b, you know, when we're looking at these. So now, I'm not done yet, but I'm super close. Because this is the formula I needed. What did I have to do to it? Yeah, that's it. I'm going to take this 100, and wherever I see an n, I'm going to put 100 in. We can do that math in our noggin. And we have it. So, what a great formula. If you're looking at that and thinking, well, yesterday I could have used that for 24, 25, and 26, you're absolutely right. We could have. So no more trial and error. If we look back at those and we say, hey, they're adding the same amount every time, we can now use this explicit formula to get them. Big time saver. Huge. Well, then what do? Because they're book writers, they take something away. That's just how they work. They say, you know what, that was way too easy for you, so we're going to take it away. What are the second and third terms of this arithmetic sequence? And I see the arithmetic, and I immediately write that down. Because you can use that formula as your guide. So I think, all right, I'm supposed to have a sub 1 to plug in and d to plug in. Well, a sub 1 is not a problem. I can see the first term is 100. It's right there. Oh, but I'm not going to be able to tell them what d is because I don't have 2 numbers right next to each other that I can get. So now I think, well, let's see. There are 1, 2, 3, 4 variables in this equation. If I can get numbers for 3 of them, then I can find d. So let me think here. A sub 1 is 100. A sub 2, A sub 3, A sub 4 is 82. Well, that looks like I have 4 numbers I can choose from. My little subscripts and my numbers on the other side. So I think, all right, what should go in for what? Well, pretty obviously 100 is going to go in for a sub 1. N. N is the number of terms. So as I think about this, I think, well, this one was already part of the formula, but I haven't done anything with this one yet. I should put that 4 in for n. And then I don't know d. But if I put the 4 in for n, don't I know the answer? What am I supposed to get if I put a 4 in for n? 82. So we did have enough information to find D. So let's go ahead and follow the order of operations. 4 minus 1 is 3. Subtract 100 from both sides. Divide both sides by 3. No, I'm not done. But now I have everything that I need to write the formula because I needed a sub 1 and D. And I'm going to have a coughing fit if I don't get a drink here. All right, so a sub n equals, we knew a sub 1 before we even started. That was 100. Plus n minus 1. What do we get for D? Now let's make a nice formula because we have everything we need to do it. So we'll distribute and combine like terms. And we're not done. But the rest of this is just going to be punched in a calculator if you don't want to do it in your noggin. Because what did we have to find? Second and third terms. So, if you didn't want to do it in your noggin, you could grab your calculator and punch in -6 times 2 plus 106 and get 94. And then -6 times 3 plus 106, 88. And we have them. Now, it's usually at this point that somebody says, Cedarholm, I found a way to find those numbers inside there by a different method. Yes, that's going to happen for some of you, and you could do guess and check to get them, but that's not what this unit is about. This unit is about, hey, we're going to learn some formulas so that people that have trouble with patterns can finally write them. They can finally do them after all these years, instead of just looking at the pattern and saying, I don't get it, I don't see it. So we have to use the formulas for these. All right, now it's the got it. So more of you and less of me. What is the 46th term of the arithmetic sequence that begins 3, 5, 7 and goes on forever? Tell me what you would write down to get yourself a start. Yeah, absolutely. You choose the right formula. What do you want to put in that bugger? Okay, so which one are we going to use for that a sub 1 this time? 3. And did you investigate already and get D? What is it? 2. Go ahead and distribute. Come up with your formula. And then double check. Make sure we're getting the same things. Now sometimes, and this happens on a test, and I just feel so bad, somebody goes to all that trouble and does all the formula and forgets to find the 46th term. You're going to get most of the points. I mean, really, after this, you could just plug it in with a calculator, so you get most of the points. But try not to go on to the next problem, especially this last one. It looks like we're going to give you this last test on the Chromebook. And you get to see one problem at a time, so you want to make sure that you're done with it before you move on. So just kind of reread the question. Put the 46 in. And what do you get? Yeah. And like I said, it really is, it's like calculator work if you don't want to have to think about that. You can get it. All right, here's B, which is like the tougher one that we did up there that took more work. So how do we want to start this when we see that it's an arithmetic sequence? Absolutely. Absolutely. Okay. What did they flat out give us? Okay. So the first term we know is an 80, and oops, the smartboard was not keeping up with my writing. And the which term? Fourth term is 125. Okay, we definitely have enough numbers, but we don't know D. So I'm going to leave D right here, right now. And that means we need numbers to put in for all the other stuff. Let's start with the obvious. What's going in for a sub 1? 80. What's going to go in for n? Yes, fourth term. And if you put a 4 into the formula, you're supposed to get? Yes. Let's find D. Order of operations says do parentheses first. Take a peek. Is that what you got? Okay. Now what do we do? Exactly. We needed that. Now what? Because I could see you writing like crazy. So what did you do after that point? Kept going? Oh, what do we have? 65. Now we're done? No, because what were we supposed to do with this? Yes, second and third terms. So again, maybe you do this in your noggin, maybe you grab a calculator, but 15 times 2 is 30, 30 plus 65 is 95, and 15 times 3 is 45, 45 plus 65, what'd you get? Good. Good. Now, I know you probably don't want to hear this, but this is as far as our book goes. Other books that we've used in the past actually say, what if we take them both away from you? What if we don't give you the first term and we don't give you D? We just give you some random ones. Emma. Oh, I wrote 120 down. Thank you. Other books say, we're going to take them both away from you. You guys are fortunate. This book says, no, we don't need to do that. That this is enough. You know, that finding D is enough. And that, I think, is where I'm going to stop today, because it's a new formula, and I want you to get used to it. So, a little practice with our new arithmetic sequences. Tomorrow we'll keep using them. We'll be talking about another part of our objective, but let's just get this in our noggins, because again, what has to happen is you have to do the practice so that you know the first thing I need to do is check and see what type is this. If it says it's an arithmetic or an arithmetic, oh, my go-to formula is the explicit formula. You'll notice we didn't even do any with the recursive formula today, not one, because the explicit formula is our go-to.